either. So this is going to be a broad structure for this talk. We'll talk about thinking through a data mining problem. Then we'll talk about 4 problems, 3 of them around data mining, more specifically around disambiguation, natural language processing, and information retrieval. Post that, the 4th problem will be about, now that you have your competing candidate models, how do you build a near real-time performance segregation platform? And finally, we'll put everything together. So data mining or not data mining, this is the trump card algorithm, and I'll let you quickly read through it. It works actually. Okay, so when we talk about data mining, we talk about 3 core things. We talk about entity, we talk about its attributes, and we talk about relationships that this entity has. So entity is essentially the core atom that you're interested in. An entity has some features that are its attributes, and the relationships just describe the connectedness of an entity as opposed to its disconnectedness with others. So much so for the data and the relationships. Now specifically, because we're talking of Python, to implement this as a tool, when you talk of the data and the data structure out there, when you have, let's say your entity has a lot of duplicates and you're interested in only deduplicated behavior, then you might want to consider sets. Or if your entity has, you want to represent it like an immutable object, then you might want to consider frozen set. Or if it has a lot of lookups, then you might want to consider a dictionary, so on and so forth. Your objective function is just a way to convert your problem into its mathematical construct. So when you say, let's say given a lot of job feeds, I'm interested in knowing which of these job feeds or profiles are more relevant to me. So my job feeds here would be my entity, the characteristics or the keywords in this would be, my attributes or the features, and coming up with this, relevance relationship would be my objective function, and we'll see that later. Now, post this, any objective function will generate your rank or the scores, and you want to be knowing, whether or not the scores actually represent the direction that you wanted to capture. And post that, of course, you want to validate whether or not your model did a good job. I got interested in this problem from Reid Hoffman's book, The Startup of You, where he talks about, given an opportunity A, how do you pivot to an opportunity B in the context of social networks? So I wanted to know, of course, which of my contacts are more relevant to me than others. So in that context, knowing your connections would necessarily mean that you have to standardize, some of the attributes of this in a certain way, and we'll see what the data set, specific to this problem was. But before that, what would disambiguation in this context mean? So information about any entity would exist as, related and unrelated information because there's nothing else left. Then you have, or you hope to be able to extract significant attributes from this, that describe this entity, and possibly describe the relationships, for this entity. And again, as we said, that objective function is just a way to mathematically represent, these relationships. Now, come to think of it, right? Deterministic, disambiguation is not a deterministic problem. The reason it is not deterministic is because depending on, what your mathematical construct was, you are always talking about some confidence, measures, and depending on, how much, let's say, human supervision or pre-processing you do, your deterministic measure might change. So before we talk about what form of disambiguation, I'll let you look at the data set that we had here. So here I have, let's say, a STEM entity. So the STEM here in this example would be SAP, which is the core entity or the parent. And it has a lot of, these child entities, SAP Labs India Private Limited, SAP Labs Bulgaria, SAP Germany, so on and so forth. So typically when we talk about disambiguation, depending on what technology you're comfortable with or what tools you use, you would talk about distance measures, and you might also want to consider query expansion techniques. Specifically about distance measures, they would have not worked in this case. Clearly, because if you want to take the distance in terms of edit distance between SAP Labs Bulgaria as opposed to SAP Labs India Private Limited, you would have to, come up at a heuristic which will tell you, how much should your distance be so that you can say to a certain extent of confidence level that, these are indeed the same entities. So you pretty much do, the thumb rule of pre-processing, which is the lower casing and removing punctuation. Post that, you do your exploratory analysis, which is just frequency plots. So if you see this data set again, I just took a set, without even lower casing. I'm afraid if this is not, pretty much clear at the back, but you do, the punctuation and lower casing, and post that is where your, essential problem really lies, post having dealt with the minor cosmetics. So we do tokenization. So tokenization is just breaking down each entity names into its, into smaller semantic units that you can process. So here, which goes by much or less the standard, you're breaking down each entity, the whole name, SAP Labs India, Private Limited, into tokens like SAP Labs India Private Limited, all of them inside a list. Then you typically handle stop words and account for internationalization, meaning non-English characters. The key assumption, as you'll also see later, is that you're assuming that all these entities don't have typo errors. And that's a very strong assumption to make, because if you're talking about frequent item set mining in this case, and we'll also talk about what exactly is frequent item set mining, you're assuming that there'll be matches because you're not taking distance measure in any case. Then we do frequent item set mining with your support is equal to number of buckets. We'll talk about this. And typically, post-processing, frequency plots, visualization. Now, we said that from each of these entities that we knew, a priori that they belong to the same entity. We wanted to know, what is the stem? Now, we clearly discarded the distance measures, and we said that post our cosmetics, which is the line number 4, we want to know, for each of these, essential keys, what are the different, tokens that will be common across each. So this problem essentially reduces to what are the number of significant words that are there in an entity name. Significant meaning how many of these would occur consistently across each of them. So again, there were a couple of options. One was you just pick up, the off-the-shelf frequency item set mining, and you just, try to fit your model to it. But here I did something different. So I knew, based on the domain knowledge, that the first word might always be the same. And of course, there are false positive and false negatives, and we'll talk about that. But you break down, in the line number 4, you break down everything into its tokens, and you start with the smallest token, right? So the smallest token here was SAP, and you want to see, whether or not SAP occurs in all, right? If you find the 100% support for this, you move on to the next largest token, which is the length 2 token, and then you try to find whether or not SAP Germany occurs in all. So length 2 here would be SAP Germany or SAP Labs, and you do all that candidate, validation. So that's another way of approaching the same problem. Of course, frequency item set mining would be great. The pure off the shelf would be great, but it doesn't work as well. Then, so this just describes the whole process. So you just take every company name, you strip out the first word, you store it as a key, and then all the values go in the same list. Now, on the local dictionary, you do a frequent item set mining, and you believe, because of your assumption, you believe that if the word is significant, then it should be present in all the baskets. Baskets meaning, if the length of my values was 37, it should be present in all 37. Then you want to treat all the values in the local dictionary as a set. So if all the elements of the local dictionary are the same, you don't need, item set mining because all of them are the same. Now, I also said that you might want to pick up the smallest list of the tokens by length because it's more optimal. And you are recursively searching, whether or not it has 100% support. Now, post that, you pretty much do, you replace all the other representations, that is SAP Labs Bulgaria, post knowing that SAP is the stem, you just replace that entity with SAP. And so that's when everything is going fine. This is a more extreme example. This is my company. So you see that, most of them have 247 more or less, but some of these entities also start with Innovation Labs 24/7 Customer Private Limited. Now, I said that you could pick up the first word as the key. In this case, if you pick up the first word as the key, it would essentially go in, in a different key, which is where you would find a different representation, and ideally it would show up in your frequency plots. So what do we do here? We go back to pre-processing and exploratory analysis, because that's where you spend a lot of time with the data, and it tells you, a priori that something didn't work as well. But other than that, there was no way using this technique for you to know that it will work. So there are a couple of limitations of this approach. One is that it doesn't account for abbreviations, meaning it doesn't know a priori that State Bank of India indeed refers to SBI, or that you have the one that we talked about, the Innovation Labs example, it is a different entity altogether, or the way you might want to treat it. Then there are certain, because it's free text, some people might write PayPal, an eBay company, or McAfee, an Intel company. So you might want to account for that separately, although it might go in McAfee and the rest of it in the value of the list, but that's a limitation of this approach. Then you need a module that will handle typos, because it's free text, and that's where the problem number 2 comes in. A couple of words about what else you could do with it. I said about the pre-processing and that you spend a lot of time with the data, which is where most of your multipass thing comes in. Then you have simulated, annealing algorithms. What they do is that you start with a good approximation to a global optima, rather than hoping to arrive at the global optima in the first place. Cross-document and co-reference is mostly what Wiki does with disambiguation, because you start with a couple of items, let's say on Berlin. It might also refer to the name of a book, for example, and that's how you resolve those. So this is just normal frequency plots, and this is just weighted by what their actual mass was. Pretty much simple. Now, we said that we assumed that the typos in the first one were not accounted for. So what are the type of spelling mistakes that occur? So there are 3 types of them. The first is the typos when I know the spelling, but there's a motor coordination slip. So motor coordination slip typically means that I wanted to type a character on the left of the keyboard, but I typed it from the right. It just swaps. And or you wanted to type Q, but you typed a character that is adjacent to that in either direction. Then there's a cognitive error. I generally don't know the spelling. Then there is phonetic errors when a word sounds correct, but it's actually incorrect. Now, we talked about the typical distance measures, but they would not work in this case, right? Which is where we wanted to see this. So we need a hybrid and contextual. Contextual because I want to be able to know that SAP Labs India with a minor error mistake belongs to the same search space as SAP. And hybrid because we have a fallback mechanism here. So your assumption is that since the typos are introduced by mistake, they should not count towards the distance, right? So we just represent the QWERTY, and of course there are other type of keywords as well, as a graph with connected nodes. And what you represent is that each of the graphs, each of these nodes, which is the key in the graph, connected to the other nodes, should not count towards introducing a distance, but under some assumptions. What are those assumptions? So those assumptions are the assumptions where we define what is a typo. So we define typos as motor coordination slips, and again this only works because you have the context. So when you're searching for SAP, as opposed to, let's see what is neighboring to A, X, right? So SAP as opposed to SXP, it might, under certain conditions, mean the same word. Then you account for the possible, then you place a limit on the total number of modal coordination slips that can occur. It cannot be possible that all of them are the slips. Then you implement your custom distance metric based on 1 and 2 with a fallback to Levenshtein. The reason, because this is the most robust of all the other edit distances, and you might want to, then just know whether or not the words were identical or taking the typos into account. A very good technique that I have seen in this space and that works pretty elegantly, when you talk about Python, is this Apache Solar that works with MySolar, if I'm correct. And what it does is that it again takes this context into account, but because you have a certain match, so in this case you are assuming that if I have 37 contacts, belonging to one entity in my network, then at least, a major mass of them will have typed it correct. So this is just a representation, and the arrows that are connected, they just don't count towards the total distance, is what I meant to say. Now we talked about this is one of my one of my favorite problems for two reasons. One, so that you can apply only to the job applications that you are more interested in, and two, so that you can find your way, hack around the system and make your application more relevant. So it was pretty motivating to work at. You do this problem in two parts. One is that you want to know, what is the possible set of relevant, job openings, right, out there. And this all is done on LinkedIn data. So there are a couple of options here, and we'll talk about them. And post what is the possible set of these job applications, you want to build a relevance score along with knowing, along with ranking them. So building your custom data set, and this again I've listed in the order of, decreasing complexity. LinkedIn, it again depends on what complexity is to you in terms of learning curve. So LinkedIn REST APIs is an option. Scraping, I'm aware there's a very good session on scraping today, so you can check it out there. With Scrapey, Beautiful Soup, Mechanize. What I used here was, pure raw HTML. It's just 2 lines of code to do the entire scraping. You'll see that later. With URL lib and some features, for exploratory analysis from an LTK. Post this, in the part 2, I used the typical TF-IDF. Instead of picking up a custom one, I wrote my own, because I don't like black box stuff. But it does pretty much the same which a black box would do. You could ideally, augment this model with structured relevance model. What it does is that, let's say you have a word, right, analyst or data scientist. Even though that word is not mentioned at all in the context, structured relevance model just try to interpret that word from the other. So it's more like, interpreting the semantic meaning of the words from the context. Then proximity search. So it's not enough to know that data and scientists occur in a document, but that data scientists occur within a certain, proximity of each other. Then you have classical IR and pattern matching algorithms here. So part 1. 2 lines of code. So you basically go to a job page. You try to exploit the commonality of a job page. So this is the the link to a job page. And what do you see here? That job index here is just a number. I believe it's a 7-digit number. So you can just have a looping construct. So you started from 1 into 10 to the power 6, and you go up to 9 times, right? And post this, you have only 4 options that exist per page. So either the job is not active, or the page does not exist, or your job passes your filtering criteria, or your job is active but it does not pass, right? And specifically, we are interested in of course the point number 3, where the job passes our filtering criteria. That is, I'm interested only in jobs that are around Bangalore, maybe because I don't want to relocate, and that are specific to a certain skill set, right? So for this one, you just build a simple CSV file. So instead of building this CSV file, you could just pick up all these URLs, and you could just pass it to the point to the part number 2. It's more it's making the whole problem more elegant. So in this, you just pass your company name, the title of position, job posting URLs, posting on functions, similar jobs, etc., etc. Now, post you have done this pre-filtering, you could actually, you remember the problem number 1, where you had, the disambiguated company names. Post that, there's also a simple module, again, on the same GitHub link, that just goes to each of these company names. It finds very concrete, information about each of these companies, which is, how many number of employees are there, which industry it is, and what is the URL of the company, what is the name of the company. You could typically benchmark it with, let's say, the information that you already have from LinkedIn, where you know that our industry is growing or non-growing. So you assign weights, prior to going to part 2, where you're building relevance. Now, before we go to IDF, TF-IDF basically comes from Boolean information, or so Boolean information retrieval is a precursor to TF-IDF. So, for example, if I wanted to know, given a document, and a base query, which is my profile, which is my resume or my profile here, how much relevant this is. And in this context, we first start off not defining what is relevant, right? So what we do is we'll just say, okay, if a certain number of words match, it has some overlap, right? But it doesn't tell me or give me a way to score my application. So which is where TF-IDF comes in. But there's one very not so good problem with TF-IDF, is because after you have tokenized this, and of course there are a lot of other problems, it just treats it as a bag of words, meaning Mary killed John or John killed Mary mean the same thing, but of course they are not, right? So you just tokenize them, break it into, so a document will have just a list of all the words, and then you do the standard pre-processing and exploratory analysis with the dispersion, with NLTK's dispersion plots, co-locations. What it does is that, again, as I said, that it's not enough to know that data scientists occurs in a certain application, but that they occur within some close proximity of each other. So that's what this will tell you about each of these documents. So typically, you can, let's say, plug the point number 2, post having done your TF-IDF or before, it just depends on how you like it. Then we do linguistic pre-processing, where we do the standard lemmatization and stemming. What this does is that analyst, analyzes, and analysis, all three mean the same thing. So when you have your final list of words, one, you need less eyeball scans, meaning you don't have to do a lot of these plots, which I said about the exploratory analysis. But more importantly, that your documents are summarized in words that actually mean the same thing, which is very semantically correct. Then you do the TF-IDF. Now, what is TF-IDF, right? So TF-IDF just tells you how important a word is to a document, the term frequency, inverse document frequency. And as I said, right, it is not enough to know that data scientist is common in this document, but that it is unusually common in this document, which is where your relevance comes in. Post that, you build an inverted index. So this step is actually more for the optimization part, but not, or the lookup part, but not so much, a core part of this algorithm. What it does is that when you do a TF-IDF, right, it just gives you a dictionary. So per document, you have, a dictionary with a, or maybe I'll just show it to you. Yeah, so here I defined my my document IDs, and as I said, I read it from the raw URL. So I just parsed the first after I just parsed the header of the job posting, and then there are keys, which is per document I have the TF, the IDF, and the TF-IDF. Typically, you would also have frequency, and you could store anything that you want to, right, in your CSV, and it has just all possible list of words against this. So this is for all the applications that you went through. And when you do the inverted index, what it does is that instead of listing it by documents, it just collects the total space of all your vocabulary. So if my vocabulary had, all my documents collectively had a set of 1,000 unique words, it just creates a lookup, meaning our data occurs in document number 1, document number 5, so on and so forth, along with the relevant TF-IDF, because that's the summary which describes your relevance. Now, post this, you just do your cosine similarity, where you just, which is just a distance metric, right? So the beautiful thing about cosine similarity is that because it's a dot product, so if a word does not exist, both in your base query and in your job posting, when you multiply them, it just turns out to be 0, obvious. And then you just normalize it by the total number of, by the length of your vector. So post this, you just output the top k relevant job postings and the top k dash words in each job feed. And as I said, top k relevant job postings is what helps you to actually identify, and top k dash actually helps you to make your application more relevant. But again, it depends on how you built up your corpus in the first place. So I wouldn't vouch for it if I'm really looking for a new move. As I already said, that you might want to augment this model with structured relevance, proximity search or pattern searching algorithms. So we'll quickly see. So if you see, oh, I forgot to maximize this, sorry. So if you see this business analyst senior manager position in Dell has the highest weight of the lot, I have no clue why. Then it has this ad tech Amazon, with a weight just below. Then it has the Amazon fashion technology. But the point I wanted to bring about here is that all these words that were processed here were unigrams, meaning the tokens were dealt with single words. So you could ideally might want to consider proximity search. So proximity search meaning the typical phase search that you do, right? To be or not to be, which is where, and by the way, this phase search to be or not to be, which has all these, all the stop words possible. So, and that's another technique to handle, such kind of stop words in the phase search context. So this is just ranking, that's weighted by their weights. Then you said that you wanted to see, the top k dash words, and by a quick scan, you can quickly make out that some words in this are relatively uninformative, like understanding, right? What does understanding mean to me, when I'm, looking for making my application more relevant, right? Or Amazon, if I'm applying for, a job with Amazon will be a relevant word compared to the other documents, other job listings out there, right? So which is where I said that, augmenting it with other, more robust or, ways that plug in better with the solution might work better. Now, all that is good. The first three I said were problems around data mining. But one of the problems that we face very often, when you are, let's say, when you want to generate a buy-in for your stakeholders, right? Typically, you would be asked, how good is your model, right? And here, the model might not mean that I have a naive Bayesian model, I have a logistic model, or I have some very cool clustering models, right? When you typically want to push these models into production, and I come from the e-commerce space, so it's like real incremental revenue for our clients. So what it means is that even before I push these models into production, I should have an aggregated way to say that my model is amongst these candidate models, my model is this good. Now, how do you do that? So you just start with all possible goals that you could have for this aggregated system. So you could say that, okay, I want to minimize the entropy of the system, meaning I don't want a lot of randomness, meaning my model will perform very good in this time period or with this data set, but in the next data set, it's like really bad. Then I would typically think about optimizing for precision and recall, which is the trade-off between the false positive and the false negatives. Then accounting for the trends, which is the velocity and the acceleration, meaning I'm looking at the first order and the second order trends. Or I might want to see that, or I might want to penalize if my model does really bad, on a certain data set as opposed to really good on other. So which is where I want to look at minimizing the bias. Now, this is just one way you could define your metric. So what I've done, when I say time period here, it might not mean that the data is actually, flowing across time, but this is like something that you can take to production, which is why I have the nomenclature of time. So you would essentially, say that instead of time, this is a data set 1, and then there's another data set 2. Against all these models, I have, a proxy for bias, type 1, type 2, so on and so forth, like we saw. So a priori, you might want to, so for all these models, I don't know which model is a good model. So for each of these models, I give them an equal weight, and I start with giving them an equal candidate population. Now, what is candidate population here? So candidate population is that, these are the number of data points that are coming to my system in production, and that will, get to perform here, right? So initially, I don't know anything, good thing, because everything gets the same weight. Then I define the model equations meaning, you have, let's say, just a logistic regression equation, and it just has, different weights maybe, or, different attributes for all these 5 or 10 or whatever you have in your system. Then you just define the metrics that we had, or, new ones that you might possibly want to have, and the threshold conditions. Now, a couple of words about threshold conditions and a success event, right? So we said that we are looking at precision and recall, right? So that depends on how you define what is a false positive or a false negative event. So which is where, defining that from, your initial data set becomes a key to this algorithm. Then you just do, because all these scores will be on a different scale, you just want to normalize them so that, you don't over account for a certain metric as opposed to others. And post that, you just want to consider, a weighted metric where if you think that, okay, for my model, precision and recall is very important, so in the final equation where I add everything together in this function, it has a bigger weight. Now, post this, you just roll this in the next period to the new candidate population. So what happens, right? You start a priori with equal candidate weights. They get some scores. Based on that, they perform. And based on this performance, it gets rolled to the new candidate population. And that happens. And the key thing here is that the scores are centrality scores, meaning, I said in the earlier part that I want to account that, I don't want to be over optimistic or over pessimistic if the models don't do as well in this period. So it's like everything matters, across time. And this is a very good algorithm that does it very well instead of recomputing everything. So these are just the models against the time, and this is, the individual metrics, and because it is in time period 1, so you see acceleration and both the metrics for acceleration as 0, and after having normalized each of them between 0 to 1, you just do a simple add. Here I didn't take the weighting. This is the last slide. So, okay, so we start with the initial, the equal candidate populations. The dots are just the performance in each, in their respective periods. And the next period, they go to a different, they get a different candidate population to act on. So this was the best performer in the first one, and this is the worst. So accordingly, you see in time period 2, model 4 gets the best of the lot, and this is assuming that the total candidate population remains constant, that is 14,000, into 5. But if you had, you didn't know what was the total, you might want to, plug in probabilities there. So if you say that, the scaled performance weighted by your probabilities. Yeah, so here are just some of the resources that I found pretty useful when I was structuring my own learning. I encourage them, you to check them out. That's all.
Yeah. Does anyone have any questions?
Hi, I'm learning natural language processing. Basically, I have a doubt where if you want to identify abstract article types like news articles, basically you can't do keyword analysis to identify if article is a news article or not.
Okay.
Okay. So how do you identify if an article is a news article or something abstract like that? Recipes are another example.
So just on the top of my head, a couple of things would occur. One is that you could probably start with a referencing database, right? So I know what classifies a news with a certain weight, right? A priori weight. So in this context, news would mean, like terror. So typically, the models that, the TF-IDF that we talked about, extensions to those models typically start with a word, and then they look at all possible corpora and document corpus. But here you could narrow down your corpus to news articles, right? So you know that this article might be a news article or not, but you know what are the other articles that are definitely news articles, right? So it's like you have a pre-tag. So that's more like a supervised learning. And then based on that, you have a certain weight to a certain word in this article that you're trying to classify, right? It's like a typical classification problem, or you might want to approach it as a clustering. It depends on what your end goal is, right? So based on that, you just assign a certain probabilities, and typically you might want to consider a threshold for each of the words in this document, and you might want to, let's say, consider, you might want to pull out, the second thought I wanted to bring about is that you might want to just pull out a document from this corpus, and you might want to say, okay, I have a random document, meaning I don't have really a bias on what this article's words were, and I have a document that I want to compare, and I'm just computing, a typical TF-IDF. So it's telling me how relevant a document is compared to this. Those are the two thoughts that I have, like, on top of my head. Yeah. How do you work on bag of words problem? So on the bag of words, you mean to say that the order does not matter here, but you want the order to matter. So that was where I was saying your proximity search comes in. So proximity search is something like, if you think of regular expressions, right? I have Mary and John, and between them I have a couple of words. So star, right? Any number of words. So you typically model out your equation in a way that you're predefining the structure, right? So Mary and John, and between them can be any number of words. So that's where, your it's not really building phrases. Query expansion and phrasing is another problem. But here you're just specifying a structure on your query. So instead of picking up Mary and John, you might want to, let's say, like in this context, right? Our company will invest in you versus you are supposed to invest in our company, right? So if you know that these, and this is where your pre-processing and exploratory analysis comes in. If you know that these phases are very common in your corpus, you might want to incorporate them, structurally.
Yeah, hi. Do we have any framework on this? Like I have a raw data. I have written a crawler and it crawled all the websites. Now, what I want to get and extract those information into a useful information and I can display. So, is there any framework?
The first question I would ask you: why do you want to build a crawler, right?
Yeah, I already built it.
You can do so good without having crawled. That was my aha moment when I spent a lot of time learning authentication. But I'll come to your question. So you're saying that post having your
yeah,
crawler,
I have the data set with me. Now what to do? What are the frameworks that I can apply to that?
Okay. So it again depends on goes back to what is your objective, right? The first slide I talked about, and I've seen this happen so much in our space that we when you're down in a problem, down in the data, you just forget what your problem was, right? So one is that you define or narrow down what your context is, right? So when I started working on the first problem, scoring my connections, and you saw just one module of it, and then I built another module. So that is the way I can just say you might want to structure your problem. That is, you know what are the websites that you are scraping or you crawled, and from that you have extracted the data. So just put everything, let's say, in a CSV file in a structured format, or in a JSON format, depending on what you're comfortable with, and then see what are the kind of interesting trends you can do. And TF-IDF, for that matter, in this case, would give you a good, beautiful summary of what the document was about. So even if you don't, look at TF-IDF, you could typically do, let's say, you find the unique number of words here, and you just do a plain counts. It would not give you as good performance as TF-IDF because it is not telling you how unusually common a particular word is to a particular web page in a website, but it will do just fine for you to know what your problem should be or what problem you should be solving.
Okay.
No need for? Yeah, so because I said that more specifically, because, any sort of crawling, right? And I'm talking of scraping, I'm not sure what he was addressing to, is pretty expensive because, all the modules you're building on, it's expensive not because, crawling itself is expensive, but because, when you're building it, it has the structure of the website embedded in it. And if you want to, have quick wins, right? You might just want to first start out by exploring the raw HTML, and it does so good. I said just 2 lines of code, so you just open a particular URL and then you just clean it up with clean HTML. You mean the ones that you would fetch by asynchronous AJAX calls? Yeah, I agree. But it's always a trade-off. It's always a trade-off.
Excuse me. Yeah. So we can take the questions offline from now.
Thank
Thanks.
you.
Thanks, Ekta. Yeah, thanks.